All right. Hi, everyone. Welcome to the third live stream of the Music Hackspace. We have Milton Mermikides. Hello, Milton.
Hey, hey. Hi, everyone.
And we have Phelan. Phelan Kane.
Hello everyone, how are we doing? Nice to see you.
So wonderful to have you guys here for the third online event for the Music Hackspace and to talk about data sonification. And I'm not sure that's quite the term you guys are using, so you can correct me later. So Milton is head of composition at the University of Surrey and professor of jazz guitar at the Royal College of Music. Is very active in data sonification for a number of years, and he recently teamed up with Phelan Kane, with an engineer and a producer, and recently also worked on acquired some new skill in digital signal processing. So together they teamed up to make Max for Live devices and further the composition machines that Milton has invented. So very, very excited to have you both here. I have a couple of announcements to make. So Milton has offered to do some live sonification of photos. So if you want to send that to him over on Twitter, maybe there's a chance that he will grab it and show it live. So his Twitter address is @miltonline. I'll put that in the comments as well. And we have this coming Monday, we have the fourth live stream with Sped Scandalis, who's a pioneer in physical models, and he's built this wonderful app called GeoShred. He's worked with Karma in Stanford to build these physical models, and he's going to talk about this. It's going to be super interesting. And then next Thursday we have Andrej Kobal from Slovenia, who is presenting his software called Granularize, which is a granular synthesizer that he made for Max for Live. So, and then we have a lot more talks scheduled until the 11th of May. So I invite you to read the newsletter, subscribe to the newsletter, or come to the website to see what's on. So, Milton, do you want to introduce yourself in a bit more detail?
Sure, I'll do that. And I'm going to start the session essentially. So hopefully you can all see my screen at the moment. Okay, so I should give a bit of a background to myself, and Fee will do the same later, which will make sense of this strange project that we're doing. I have a sort of unusual background in that I grew up at CERN. My dad was a nuclear physicist, and I used to come home at the end of the day to find these sort of scribbles on the dining room table, which are subatomic particle paths. And I thought everybody's dad did such a thing. They basically discovered the fabric of the universe and then would watch the Muppets and carry on. And I fell deeply in love with science, just the discovery behind it. But at the same time, my uncle gave me something called a cassette tape. You might have heard of it. It's like a retro MP3. And on it, one side had Sergeant Pepper's, the other was Magical Mystery Tour. And it completely blew my mind. So I fell in love with science and music at the same time. And I never saw them as separate. I was a kind of odd kid, and to prove that, here's a picture of me at the time. And there's actually quite a good metric for how odd I am. It's basically the distance between lapels. So that's how awkward I was. And for me, music and science were the same, but the education system at the time pushed them apart as wide as my lapels were. And I was told that one was serious and one was play. But I've never quite let go of the fact that they are in fact fused deeply. So let's talk about science and music. So there are certain questions we can ask, like how long have we been making music? Well, this is the oldest musical instrument found. It's 40,000 years old, and it's carved out of the tusk of a woolly mammoth. So we've been making music for tens of thousands of years, perhaps more. And we've been doing it all over the world. There is no culture which doesn't have music. And to give you some idea, Africa alone has 3,000 distinct musical cultures that have evolved over millennia. So one question we might ask ourselves, and a lot of men in their 30s ask, has all the good music already been written? This is the question, since we've been doing so much music for so long, has it all been written? And the short answer is no. And I'll give a slightly longer answer. We as humans are quite impressed with our own imaginations, but we have fairly limited imaginations. As an example, if you imagine the number of ways there are to shuffle a deck of cards, the actual mathematical term is 52 factorial, that 52 exclamation mark. You wouldn't think that's so big, but in fact, it's a number so enormous that no deck has been shuffled the same way twice. We can guarantee it. And it just seems like it breaks all common sense. So let's do it another way. Let's talk about the number of drum beats we can come up with, and we'll keep it super simple. Imagine we can place a kick anywhere in a 4/4 bar on any eighth note. Every combination of kick, snare, and let's say hi-hat, 16 in a bar. How many of those are there? Well, 2 to the power of 8 to the times itself and 2 to the power of 16. That's the number of the simplest ever drum grooves you can think of, and it comes up to this enormous number. So at 120 BPM, it would take us 272 years just to listen to them. So we start to get an inkling now of how enormous music is. And it gets worse. If we think that music is not just placements on a grid of pitch and rhythm, but sound itself, then we can think of how many CDs could we possibly come up with. Imagine a CD as just a string of ones and zeros. It could be all zeros, all ones, or any combination of them. So how many are there? Well, imagine a library with every single possible CD you can imagine. It includes all your favorite albums, all your least favorite albums, and all the ones you can imagine. So Lou Reed singing with the Muppets, Beethoven's Ninth. Every single CD. How big would that library be? Well, if we stacked up all those CDs, they would go, this is how many there would be. Let's call it a miltillion. How big would that library be? Well, it would go beyond Everest and reach the moon, but go way past the moon to reach Saturn, and we still wouldn't be anywhere near done. It would hit the edge of the known universe, but we still wouldn't be done. We'd have to go round the universe to start fitting this library in, and we'd have to go around so many times that if we had a marble for every time we went round the universe, we could fill the universe up with marbles many times over. So the short answer is no. The longer answer is hell no. So even if the tiniest fraction of this music is so-called good, then we haven't begun to scratch the surface of what music can be made. There's still more than enough original music for all of us to make. There is an abundance. So the challenge really is, how do we choose from these huge amounts of music that's available? And what composers do and musicians do is they invent styles and instruments that limit the number of music we can make, so we can work within those constraints. So Bach's 24 preludes and fugues, for example. And sometimes that constraint, that limit, is written in, like this one-note samba. So if you only got one note, you better have nice rhythms and harmony in order to balance. So I've been always fascinated by how people make music and that constraints that they use. But I am even more interested by meaningful constraint, making choices based on things that aren't arbitrary. You may have heard of the composer Bach, and he was fortunate enough to have as his last name a 4-note melody. In the German system, they go up to H beyond G. So his last name spelt this sinewy little melody. That's his motif. And he used to use it in his music. Here's another representation where those 4 notes are represented by 1 dot on the crucifix of 4 clefs. And Bach used to embed this, his name, into his own music as a sort of compositional challenge, a joke, a tribute, a sort of early Easter egg, if you will. Most famously, he did so on his deathbed. In his blindness, he was dictating the art of the fugue to his son. And this inscription here says, at the point where the composer introduces the name Bach in the counter subject to the fugue, the composer died. So be careful when you're doing this. And here it is. He essentially signed off. I'm just going to play you that extract, and so you can hear it. I've put some bell tones. And I love the way it tails off, which gives you a hint of this compositional process. This idea that we could make music from our own names is hugely interesting to me. And there's a long history of it. It's called a cryptogram. There was a German system devised where you could, if you had other letters in your name, they were translated into notes. This is called the German system. Shostakovich at the beginning of String Quartet number 8 does the same. His DSCH in his name spells this beautiful Russian signature, and he uses it throughout his String Quartet number 8. You can hear it clearly at the beginning of this movement. And many other composers have done it since. The French had their own system. So JB would be in here, would play this melody. That's quite... You could write a beautiful piece with any of your names. It's kind of an arbitrary system. The B doesn't mean anything, but I've since invented my own, which maps letter frequency onto note frequency. So if you're on the key of C major, for example, the most common note is not C, but G, then C, D, F, D. And in the English language, E, T, A, O are the most common letters. So you could translate whole works and texts, and the letter frequency would map onto melodic tones. Now, this was obviously done by hand and in very small numbers, but what we've been able to do with Phi is build tools that can engage with this directly using the German system, the French system, and other systems we've invented to automate this with Max MSP and Max for Live devices. So I'm going to hand over to Phi to show this first device.
Hello everyone, thank you Milton. So fantastic, I hope you can hear me and see me okay. I'm just going to share my screen for you. So before we get into a little bit more information about the devices, here's a little bit about me. I'm an Ableton certified trainer. I've been active as an engineer and an educator for 20 years, and I've been collaborating with Milton for about 3 or 4 years on various devices. I also make some software packages for Max for Live devices and racks, etc. I've got quite a few freebies available on my site. So it'd be nice to see you guys in the future. So please reach out and look for us under Meta Function. and we can maybe sort of share and collaborate some more Max ideas. So what we've got here in our first example this evening is our little Max device we've created here. So what this allows us to do is take the cryptogram sequences that Milton was discussing and deploy the various different systems he's got in order to generate musical motifs. So for example, down here I have the word Bach typed into my little system, and I can actually trigger each individual element of this phrase via MIDI. So I can run a little MIDI clip at the actual device. And what we're really doing here is triggering each of the letters inside that particular phrase or string and converting that into MIDI notes. So we're really taking a string and we're converting a text string into musical MIDI note values, which we then can manipulate through our Ableton Live project. So we can literally type anything we like in here, and using our different systems of translation that Milton discussed, we can actually create any melodies out of any particular phrase or expression or set of words we like. So we can see on this particular example, you might see there's a few musical rests in there because the system I'm using that Milton discussed earlier, which contains all the rules based on the mapping and translation of the different letter systems over to the different musical interval values, sometimes it might involve a rest or a space. So this is the sort of general device, and we're going to stick this up for you guys on the Music Hackspace forum. But what I really want to show you a little bit more detail about this is actually how this was built. So my sort of big role within this collaboration with Milt is really to sort of provide a bit more of the technical infrastructure within Max and Max for Live. So what we can see here is our first patch. We've got quite a few to show you this evening. This one is probably the most simple actually. So what we're really doing here is using the Max for Live or the Max text edit box, and we're able to actually bring over any character string from ASCII, and we're converting that into an integer based number. So, you know, we can see that we've got here a couple of sort of familiar Max objects. This is the ASCII to integer object. We're using this to directly convert an ASCII character value from a string or a character or a car, as we say in computer science, and we're converting that into a string of integer values, which we're literally translating over into MIDI note numbers. So this gives us the flexibility to sort of, you know, use any string the user might want to type into the actual system. What we can see on this part of the patch over here, once we've converted our characters or our letters from the ASCII value into an integer, we can then use different types of rule-based systems, as Milt discussed, to quantize the pitches. So inside this particular little object I've got here, this is a Max Cole object, and all you Max nerds would know this object really well. This has got all of the intervallic rules inside it that Milton devised to be able to provide our transposition and translation into different musical systems. So you can see here the top one would be maybe pure ASCII, we can see, or off rather, then we have a pure ASCII, which would be the next index into the Cole, then you've got the German, etc. So we're using sort of this as a quantization system basically to manipulate the MIDI intervals into different sort of translation systems. And as you can see, they get a little bit more elaborate as we move down the list. So once we've done our little bit of translation by using our Cole, we're then able to throw these MIDI notes over to the sort of top right-hand side of the patch. And this is the bit where we're sort of piping data and numbers within the patch through over to this section over here, where I'm sort of clicking with my psychedelic mouse, and we're generally here generating MIDI notes here. So this device doesn't really produce any sound itself. It's not an audio device, it's a Max for Live MIDI device. It literally converts string values from ASCII into MIDI notes, which we then kick out via our Max Note Out object. Having this in a Max for Live device means we can feed it off into any of the devices we want to use in live, whether it's wavetable or operator or analog, or even running it through to a third-party VST audio unit plugin. So this is the cryptogram device, guys, which is the slightly more simple device which is available for you guys to explore the forum. There's a few more parts of the patch that are quite interesting. We can see over here we've got some different tools that would help us actually showcase some different notation systems in the patch. There's a few visual tools inside here, but the crypto cryptogram sequence is based on this methodology that Milt discussed of using different strings in names. So guys, if you've got any questions, please don't be shy, throw them into the chat, because JB's going to give us an opportunity to sort of talk a bit more about, you know, some of your feedback maybe. He could throw questions into the chat for us from Facebook. I'm just going to go back to another quick screen share for you, and I'm going to show you another patch that we've developed which extends the idea of the cryptogram. So this one is a slightly more complicated device, but it uses a similar methodology where we're taking different letters and characters and words and expressions and converting that information into some sort of musical basis. Yeah. So this one is actually called a cryptogram sequencer, so it's a bit different. And this is trying to sort of maybe extend some of the functionality that we saw a second ago, which is quite interesting. So, for example, on this one, let's type in any expression we like. So we're going to type in hack space. Let's see if we can actually spell correctly today, Phelan. There we go. So what I've done here is I've managed to take my expression and I've populated it out into a little matrix. So this is basically like a sequencer. I got inspiration from this one by going to visit the 100th centenary of the Bauhaus, famous German art school, at an exhibition here in Berlin a few months ago. And they had this interesting sort of visual tool you could play with where you could type different letters and words in. So this one, what it's done is taken my string and wrapped it around this 64 cell grid. So when I trigger my live set, I'm actually running each of these different characters, and they're being triggered through our translation system that Milton mentioned earlier, to be able to provide some sort of notation system, which will then firing off into whatever musical device you might want to play with within your set. In this example today, we're using an instance of Ableton's wavetable. And obviously we've got all the typical rules we saw earlier, where we might want to go into some of Milton's scales that he's developed. You've got different transposition happening here. Maybe there's a couple of French ones that we mentioned. But the interesting thing for me for this one is the fact we can actually manipulate the direction of the sequencer. So I can, as you can see, it's going forward. We've got multiple directions, so now we're actually triggering each of the cell and then moving in a backwards direction. So we've got a forwards and a backwards. We can actually also make the rows go down, so we can maybe manipulate the different directions in terms of sort of like the column being the important part of the sequence. We've also got down here a few other funny ones we invented where we can skip the occasional row. So there's a whole bunch of like really crazy stuff this can do. And what's quite clever is it's really based on, you know, whatever you type in to your string really is going to give you specifically different results each time you play it. So really it's based on a sort of numerical analysis of MIDI values, if you like, driven from data from the characters. You've got multiple ways to manipulate these. You can play your sequence back in alternative directions. My particular favourite is random. And we've also triggering this over the live BPM and the tempo. So this is all actually clocked to the host sequencer's BPM. And we can choose different musical subdivisions to be able to sort of trigger each individual cell. So for example here we're going an eighth note pulse. Let's go back to 120 beats a minute. And we're obviously running sort of forward here. Let's go to pure ASCII scale, so we should trigger every single note here. Let's maybe go down a couple of octaves just to get it back into a better range. There we go. So you can see, guys, quite a bit of flexibility. It's really like a step sequencer for letters, which is kind of cool. So that's quite interesting. Let's have a look inside this one, because this device is a little bit more complex in its mechanics than the previous one. Obviously, you know, if you're a Max fan, you're probably familiar with the fact you can just like hack devices and, you know, work on existing work. So we obviously took what we developed for the original cryptogram and we sort of developed that as a further concept. So we're using quite a lot of the same methodology of the building and programming techniques as we obviously did in the previous example. We used the text edit object here from Max to pull our characters from the user as a string. But this one is sort of where it differs a little bit. So what we've managed to do for this one is actually, it's a little bit more complicated. The actual device that's really working at the core of this particular object is a jitter matrix. But obviously we're not really sort of set up here to do anything within a visual jitter-based world, but it's actually using a cell block, which is a jitter object. And I guess in a way this is a little bit like a spreadsheet object for jitter. So what we managed to work out for this one is we can use this as a step sequence by stepping through the individual different elements of the cell block. We can use different numerical values to trigger onwards and forward through the cell block. So that was quite exciting to be able to discover we could do that. However, the problem is, how do we populate the letters into the jitter cell box? And that was actually really complicated. So I think this took me 18 hours of programming in Max for about a week and a half to do it. And the only real solution I could find was the dreaded, horrible JavaScript. Yeah. So, obviously this gives you a whole bunch of great functionality to open up into what you could do with Max. I'm able to implement a whole bunch of sort of JavaScript coding here to do stuff that would have been really complicated to do with Max objects. So I've managed to save a little bit of workflow to sometimes just hard code it, This is, again guys, these devices are quite sort of work in progress. They're by no means completely finished and they're by no means optimized. So you have to forgive my rather Luddite use of JavaScript. A lot of this could be optimized a little bit, and it's definitely, I'm failing for the do not repeat yourself coding rules that you might be familiar with. But I'm using this bunch of JavaScript to literally hard code each character from my string into a specific cell in the jitter matrix. And doing this is sort of based across the numerical position, if you like, of each of these objects. You can see if I were to zoom in a little bit here, my JavaScript allows me to take my message and populate X and Y coordinates followed by the letter. So you can pretty much see you've got music hack space is inside this Max message, but I've had to prepend each individual character in the string with an X and Y coordinate, which matches up to my jitter cell block, which I can then drive as a sequencer from max tempo. Yeah. So that's a little bit more of a complicated device, but it does have its sort of original design methodology based in the previous example. As we can see here, we're sort of kicking out data from our matrix and we're following back through to the translation systems that Milton developed that we've got inside our cult object. So again, we're being clever and using existing patches that we developed in previous objects. And then finally, again, we're kicking all this out into our familiar Max for Live, Max note out object. So again, we're just really generating MIDI interval, MIDI pitch values and velocity values. Yeah. So this one's a bit more fun, I guess, because it's got a sequencer nature to it. But there's the first two devices that I'm going to show you this evening, guys. So that's the whole mentality of our crypto and our cryptogram sequencing. Yeah. So I think I'm going to hand back to Milt because he's going to move on to the next subject matter this evening. And he's back. So thanks for your time, peeps. See you a bit later.
So I'm back. Excuse me, mic was muted. So crypto is the mapping of letters to the musical world, which is conventionally these are separate domains, and it's really beautiful because it's like leaving a signature, something of you in your music. But we can go beyond that. And one composer who I adore is Villa-Lobos, who was a Brazilian composer. And he moved to New York, where he made much of his career. He's now still very famous in Brazil, and he's on the money, as in he is on their currency. So Villa-Lobos moved to New York and was struck by the beauty of the New York skyline. And many composers are moved by visuals and visions, but what they tend to do is get a feeling and then try and replicate that feeling in the music of awe, of inspiration, and so on. Not Villa-Lobos. What he did is he took a photograph and mapped it out onto graph paper with time running from left to right, and pitches, you can kind of see them here, re, fa, mi, fa, on the y-axis. So what he got was the outline for his piece, not just one melody, but multiple lines. And he wrote a piece of music called the New York Skyline Melody, and I'm going to play a little bit of it for you now. So what we get is the music of architecture here. It's one of my favourite bits, this sequence here. And this descending bass line. And so an architectural style is replicated in the music, like these parapets here. And repeated below. I find this utterly awesome. Not only is it a beautiful piece, but we have moved music beyond its insulated domain as a way of speaking about the universe outside of itself. And we can do much more, of course. So there is a music of any object of the physical world. And I have I think 16, 17, 18 years now been just fascinated with this. And I've done, as you'll see, dozens and dozens and dozens of projects, and we'll never run out of music, as I mentioned before. So, for example, in 2004, someone showed me this text by the poet-philosopher Rilke, who noticed that the searcher, this is a human skull, by the way, has this groove on it. And he wrote this essay saying, what would happen if we tricked a needle, a phonograph needle, into playing this groove? What sounds would emerge? What feelings, awe, incredulity, fear, and which of these prevent me from naming this primal sound? Totally beautiful idea, totally hypothetical in 1919, but in 2004 I did just that. Using Max, I converted this particular searcher into music. A searcher looks like a groove, and in fact this is a groove of a record needle, so they map really beautifully. I had a question, I think, about the Villa Lobos, about the constraint of the pieces he shows. It's a chromatic scale on the left hand side, so and he used his harmonic skill to make it work with some harmonic devices in between. I hope that answers your question. So this primal sound was hypothetical in 1919, but in 2004 I managed to basically convert it. I'll play you a little bit of that now. What I love about this is that with all the coffee in the world, I would never have thought of these sounds, but somehow they were there in the universe, ready to be plucked. And this is the primal sound of actually a Victorian woman who would have lived at the same time as Rilke. of course, it's actually an ancient idea. Pythagoras talked about the music of the spheres, the sound that the universe makes as the planets spin. And even Kepler in the 17th century came up with scales based on the orbits of various planets. So the scale for Venus is pretty constrained, and that of Mercury is very eccentric and wide. So this idea that the solar system, the universe itself, is breathing music is an ancient one. But again, it can be reinvigorated by technology. So in 2015, I worked with a NASA scientist, and I took data of the solar system, how fast each planet spins around the sun. Now, if you sped up, for example, the orbit of Mercury fast enough, you'd start to get a rhythm. All you have to do is keep doubling it until you get a pulsing rhythm. And if you speed it up even further, you enter the pitch domain. So I was interested in the rhythm and the chords that the solar system makes if we speed it up enough. So let me find that for you. So there's Mercury, high and fast. And these haven't been made into nice scales. They're completely microtonal and micro-rhythmic. I love Mars. Lower and slower. And we can make these for any system, planetary system in the entire universe. I've done it with 4 other ones, so I'm not going to run out anytime soon. So I don't know if your speakers can hear it, but when we get to the more distant planets, we go super low. I'll just move it onwards so we get the final chord. And we can make music from anything. I don't know if you've seen this video of the pendulum swinging, but we can generate all sorts of arpeggiated patterns from that, from these sort of physical realities, and listen to their hidden music. Get these gorgeous arpeggiations. So you just imagine it's a keyboard on this right hand side. So we can see that we can do this sort of thing not just as a form of constraint, a creative constraint, or a form of signature, but actually as a way of sourcing otherwise hidden music. I've made sequences out of the Rubik's Cube, but I won't show you just that now, just in case you think I'm a nerd. So this these devices are traditionally, well, these sort of transformations were done manually, and a lot of the ones I did in the past were manual, so that pendulum took a while. But as we start to hook in technology, we enhance our ability to to tap into this hidden music of the universe. And there are 3 devices that Phi developed to help us do that. I'm going to pass over to him to talk about them.
Okay, thank you, Milt. So guys, just before I get into that, I just wanted to answer a couple of questions that JB's put into the chat for us in Zoom so we can see some of your guys' feedback. So I think Magic Pocket Music was asking about the crypto sequencer, and it is actually a 16 character limit. You've got 16 characters you can stick in, but it will actually loop any string. So if you were to type in maybe a 3 character expression, it will loop that expression across the 64 cells of the sequencer. So it automatically locates the end of the phrase and duplicates it, and then just truncates at 64 if you like. But there is up to 16 characters. And obviously what's a bit more interesting for the sort of musical patterns you can get out of this is if you're actually using a collection of slightly more weird and wacky character lengths, like, you know, maybe something that isn't an even number would give you a more interesting type of musical result on the sequencer depending on the direction that you're using with the sequencer. So anyway, so that answers that question. So guys, again, feel free to put more questions into the chat if you have any queries. We're here to answer them. So here's a little bit of an example for you of another type of device we developed, which is using asteroid data. So this one is actually pulling down real-time information from the web, from NASA's website, using NASA's API to be able to manipulate and turn data surrounding near-Earth objects into musical information. So as if you haven't been nerdy enough this evening, now you're getting super nerdy. So what this is sort of based on really, guys, is I hacked into this quite well-known pack that Ableton have created called the Connection Kit. It's free. I thoroughly recommend you go and grab it. It's awesome. There's loads of really great stuff you can do with this. A good friend of mine from Leicester, Mark, has used it to create all sorts of interesting Lego robots that control live sequences. What I particularly did is I pulled in the weather aspect via the JSON device. So I use this one tiny little aspect of this device, which allows me to then pull out weather data from a thing called the Dark Sky API. And the Dark Sky API is a global weather API you can tap into in JSON data to pull out, you know, the temperature in Cairo or the wind speed in Berlin. So as soon as I managed to sort of work out that I can hack into the existing device that Ableton provided, I started to experiment with putting different APIs in there, and I come up with a couple of devices that Milton mentioned. The first one is the asteroid data, and there's another one which is based across weather patterns. So first up, this particular device, the first device, the asteroids one, is using NASA's API. It's open source free API. You just need to sign up for a key. Once you get into your key, you then basically just got a ridiculous amount of information you could pull down. And it was a bit hit and miss trying to work out which ones might be useful. For example, the one that we sort of implemented is the Near Earth Object Web Service. So this is basically a database of any potential asteroids that have gone past planet Earth in the last 40 years. So it's literally pulling down all of this information using, you know, API keys and URL addresses, real time inside a Mac's device through the internet. And we just managed to sort of work out different parameters that we felt might be useful to manipulate and to, you know, pass and turn into musical information. But this is the tip of the iceberg because there's like so much more stuff. I mean, this was another one I wanted to get into, which is the exoplanet archive of all the discoverable exoplanets in different solar systems in the universe. You know, there's literally like enough stuff to keep you going through several lifetimes of lockdown on this website if you're a bit of a Max nerd like me. But you know, definitely like a huge resource of crazy information. So this one, what we're doing here, again, is acting a bit like a sequencer. We've got over here, this little drop-down menu allows me to choose a specific asteroid from the data. And you've got different years in here. So these are actually labeled after the specific terminology or serial numbers that NASA gave to the different asteroids. So we're currently going to be using 1996's asteroid called TOS. Don't quite know why it's called TOS, but that's the name NASA gave it. We can see on the left hand side over here, I've got a little display panel that shows me the the actual specific piece of information I'm looking at. So for example, if I move to a different asteroid, it takes a few seconds to upload it, but we can see we're now looking at a different piece of data. So this one obviously does rely on having a real-time internet connection. If I scroll down here, you can start to see some of the information you can pull from the API, the estimated diameter of the asteroid, its maximum size, it's how close it got to the Earth, was it a near miss, etc. Down to sort of things like its miles per hour, its orbital information. So from a process of trial and error, me and Milt sort of worked out how we could maybe grab some of this information. So what we can see here is we can trigger a call from the NASA API at a clock rate determined by Live's BPM. So we're going to be working maybe on an 8th clock. I can trigger a specific pitch, velocity, and a controller. So there's 3 parts to this patch. The first one is the pitch, which generates obviously the pitch class. This is determined by whatever data set you choose in this menu. So for example, I'm going to use what NASA call the ascending node longitude to calculate the pitches for my musical piece. Now I don't honestly really know what that means in terms of NASA scientific information, but this parameter is now generating some raw data, and as we can see here, this information is being pulled down off the net. It's got 167.38. I'm using that information to generate a pitch class. That pitch class I'm actually also randomizing slightly, so you can see you've got a little randomization control at the bottom here, and we're using that to send off to my wavetable device. So we're actually triggering this little contour, this little melodic line, based on the pitch information from that parameter. So if I change the asteroid, it takes a few seconds maybe sometimes to come through. We should technically probably get some different types of information. So I could actually add some randomization to it as well here, adding some octave jumps. I could maybe change the rate a little bit. I could maybe do some scaling of this information. So you see now I've moved up and constrained some of the notes to be within maybe a different octave. There we go, so we're now going from the 2nd octave. Or if I wanted to maybe go from the perfect 5th of C major in the bottom octave here, you see we can constrain and scale the data. So we've got one of these for each type of information, guys. We've got one here for velocity. So we've got 3 arbitrary classes where you can sort of really choose what information is driving what. So you've got a pitch class, got a velocity class for dynamics, and obviously you've got a controller class as well. So the first 2 are hopefully quite obvious. I could, as you can see here, adjust the dynamic contour. I can make my velocity only, very quiet here, or I can increase the range. I can scale the information. So hopefully the velocity and the pitch is quite obvious. The controller's a little bit wacky. So this is like the second part of this device. It's this little section over here. You might notice we've got some filter sweep movements happening inside the wavetable device. So as I move about over here, I've actually mapped over this information coming from the API. I've converted it into an audio signal. I'm allowing the user to scale it a little bit, and I'm using a live object model to then map that parameter over to any parameter in the DAW. So I've then got an opportunity to convert, the minimum orbit intersection of one asteroid into a cutoff frequency sweep. Yeah. So we're sort of using the live object model and the live API to be able to pull API data from NASA, convert it into useful pitch classes and velocity, but also to convert it into automation data. And I can obviously record this, I can control it, I can scale it, I can manipulate it, and I could, if I wanted to, actually map to any parameter that we've got available inside our devices. If you guys have ever used the quite well-known Max for Live LFO objects, I literally hacked into that. So I'm using the Max for Live LFO object as a basis to hack into that to be able to produce automation data, which I can then use to control any other Ableton object. It could be a reverb parameter, it could be a synth cutoff frequency, any device that Ableton make. The live API is completely bonkers, guys. You can automate your DAW, it's nutty. So just a quick overview of the patch. This one's a little bit more complicated. So what I'm really doing here is I'm putting down a specific URL from each individual object that the user might select, each different type of asteroid. So you can see here I'm actually using the API address here inside this dictionary object, and I've actually got my little personal key that I've made up, which is free, and I'm pulling down a specific near Earth object number, which generates information about one specific type of asteroid. So this is using dictionaries. This is the sort of the dictionary object in Max is allowing me to store JSON information pulled down in real time from the web. Yeah. And then obviously that dictionary information is also can be parsed. So you've got each individual asteroid, as we saw on the NASA website, has got a ridiculous amount of stuff in it. So we're only really using a fraction of this particular bunch of information. You know, you might recognise some of these parameters. Here's his minimum orbit intersection. So I'm literally only pulling down a certain tiny portion of the dictionary, really, just to make it a bit manageable for the user. So what we've got here is a couple of options for the user to be able to select what type of information they want. We've got various dictionary calls we're using to be able to pull out that information from the dictionary we've loaded from the API, and we're then converting that information using some transform objects like the probably quite well-known max scale object, so we can do different types of data transformation, and then that is literally getting converted into MIDI notes again. Yeah, and we're using a little internal clock that's pulled from the max BPM and live tempo to be able to trigger off individual, you know, notes as if it's a sequencer. So this patch again, guys, a little bit more complicated, but you might be able to sort of think of this as like 3 duplicate sections. Over here you've got this is the pitch class section, and then you've got the sort of middle bit in the middle is literally a complete duplication of it, but it's been hacked and programmed just to give us velocity information. You can sort of see the cable here is providing a velocity information to, you know, allow us to have a full MIDI message, if you like, a MIDI note message. This section on the right hand side over here, this is producing the information for the live object model to allow us to do automation data. So this one's a bit different, and we're actually having to go through a little bit more of a complicated system down here by using the live remote object to be able to assign that to a different parameter. So this is really why these devices, guys, were designed to work with Max for Live. You have to use Max for Live with these. The live object model, live remote object doesn't work in Max. It only works in Max for Live devices in Live. So yeah, these devices are really destined for use within Ableton. Obviously, you can hack them and put them into a standalone Max version if that's your cup of tea. Yeah. So this one's got 3 sides to it really: pitch class, velocity, followed by some controller-based information, which is actually using a signal object to convert numerical data from our land of Max into what we used to call MSP, into Max signal processing information, the signal path element. So guys, I hope that's a good little oversight for you for the idea about what we've got going on this evening with the asteroids example. I'm just checking out any other questions we might have inside the chat. Doesn't look like it, but I'll be hanging about for quite a bit this evening, guys. If you've got any more specific questions, yeah, so please do just throw them into the chat. We'll load them up. I'm just going to quickly load in my next little example for you, which is very, very similar actually. So we just saw a version of asteroids, if you like. So what we want to have a quite final sort of look at, if you like, is one that's going to be maybe also working on a similar methodology. So we've got a couple of similar devices that work within our system, as Milton was sort of saying, using different types of JSON data, different API information. So here we go. So let's have a look at this one. Okay, so this is the weather report patch. So this is sort of very similar. It's using the dark sky API. We've got a pitch class, we've got a velocity dynamic, and we've got a controller. So for this one, we're actually using a similar bunch of information or similar program methodology to produce the data, but it's based on a completely different data set. It's based off our dark sky API. So we can see inside here, you know, we've got a very similar looking patch, but it's actually using a completely different bunch of information. We've got 4 cities so far we've programmed here. We've got Berlin, London, Pasadena and Tokyo, and these were chosen because they're the 4 cities that have Ableton have an office in. Being Ableton certified trainer, a bit of a fanboy, so we decided to sort of put Ableton's HQ cities into our weather report information. So again, you know, you've got a trigger system here, you can control the rates. We can maybe do different types of note duration. So there's a couple of sort of musical parameters that you could use to, you know, to shape, for example, the output. Let's go to a half note trigger with maybe duration of a quarter note. We could maybe scale some of the low of the pitch. Let's maybe give it a bit more of a constraint. There you go. We could maybe add some perfect fifths in as a random or an octave. We could maybe do a similar thing with some dynamic control. So again, we're pulling down different information. So in this particular patch, the sort of data set's obviously different because it's weather. So we've got stuff like temperature, dew point, humidity, pressure, wind speed, wind bearing, cloud cover. And we can, you know, we intend to add some more into these as we develop these devices more in the future, guys. So we took a similar methodology when we built this one with pitch class and dynamic or velocity, and also some sort of controller information to allow us to map that as a automatable parameter. So in this particular one, I'm actually modulating the wavetable position in the oscillator. And you can see over here, if I manipulate my little parameters over here, we can get different types of wavetable sweep depending on the actual data source we've got. So another thing to be aware about with this example and the previous one, we're sort of cheating a little bit because you can see here we've got the Ableton scaler device is sitting between the Max for Live device and the actual synth that generates the sound. So we are being a bit naughty and we are actually providing some pitch quantization to all the musical notes to work within a specific diatonic scale. If I switch this off, we're probably going to end up with stuff that could be super interesting, but you know, it might not necessarily conform to some more pleasing musical results. But you know, as usual guys, your mileage may vary. You know, I'm sure you can hack into this and make it microtonal. I'm sure there's a whole bunch of stuff you could do that could, you know, make it more fit for purpose for your use. But just for sort of simplicity tonight, we're doing a little bit of basic pitch quantization with the Max for Live, also the Ableton MIDI effect, which is the scaler device. So having a quick look at the patch, just before I hand back to Milton, we can see pretty similar methodology actually, because we've got a dictionary where we're pulling down the different URLs for the API from Dark Sky that provides the weather data. So this is the data for Berlin, this is the key for Berlin on their website. We've also got maybe a key for another city here, so I believe this is the second one in the menu, which is probably Tokyo, so that's the specific key for Tokyo. So all this sort of dictionary data, again, is pulled through and we can then access it just like a database, I guess, pull out humidity, pull out wind speed, pull out whatever the user wants. So in a way, what we've done with these Max for Live devices is create an interface that allows you to grab these numbers through some sort of, you know, user-friendly musical interface, we hope, yeah? And that sort of information you can scale and manipulate and twist and, you know, define how you want the parameters to affect your musical result, yeah? So again, guys, this one, the weather report device is quite similar to Asteroids in that it uses an API. So the interesting thing for me and Milton about sharing these with people is technically you could hack into this device and you can go to pretty much any API you can find in the planet and pull down pretty much any data you want from anywhere. So, I mean, one of the ones I meant to get around to having a look at is the Transport for London API to find out, you know, how many buses are going from Baker Street to Oxford Circus or something. You know, you could probably pull out an API of, you know, any information you can get offline that's free. APIs are generally open source. So quite interested to see what you guys would come up with by hacking into our devices. And the weather report and asteroid ones, it should be fairly easy with a little bit of messing about and jiggering and pokering to be able for you to put any API you like into these devices. Yeah. Okay, I'm going to come back to maybe my last little section for this evening, guys, to show you the final device before I hand back to Milt. And this is our climate report device. So this is a bit different, but it's still utilising the same principles and methodology that Milton discussed in his slides. This one is actually not necessarily pulling information off an API in real time. what it's doing is loading in climate data that we have stored inside the patch in a table, in a cull. So I'm just going to quickly jump up to 1993 because that's when we have a more complete set of data. I'm going to press play. This is a sort of polyphonic instrument, it's multi-timbral. So you should be able to hopefully see here I'm running my first channel, which I can activate and deactivate. I've got a speed, and I'm using climate information to manipulate these notes and to maybe control aspects of the velocity. And we're using here a temperature anomaly. And we're using sort of that for the pitch glass, and we're using CO2 for the velocity. And you see we're actually scrolling through the years that have all the data from, you know, our table that's been collected. But the interesting thing about this device, guys, I can switch on my second channel, and I've got a second one that's running completely independently. So the second one, you can see if I move between the devices, the entire display will change, yeah? So there's a whole bunch of sort of show and hide going on inside the background here in the Max patch to update the interface, but we've got completely sort of separate possibility to manipulate all this information completely differently, you know. And if we go to the third one, activate that. This one's been deliberately set to have a very slow half bar trigger, and it's been scaled to play a bass line, so we can, you know, transforming the pitch classes down into lower octave. Here's the fourth one, and this has got more of a quarter beat pulse. So there was a bit of musical sensibility in this example because each of these different objects, if you like, have been set up deliberately with some vaguely musical parameters. But what's interesting about this is this device lives on this channel and there's nothing else going on. It's just this by itself. All the instruments are running on a separate track. And we've actually used, again, our scaler device to cheat a little bit, so we can actually, you know, have a little bit maybe of some diatonic information by a bit of pitch quantization. But what's quite clever here is we've used a device we've built together to do some send and receive. Now, one of the things about using the Max for Live integration to have all the great functionality of Max inside Live, sometimes it's a bit tricky to send MIDI messages between adjacent tracks in the same project. So what we managed to work out is we can do that via a little system of additional sort of patching and different additional objects. So let me just unfreeze this device. This one again, guys, is a little bit more complex. It's probably a bit scary when you look at this. When you make something like this, you sort of know it really well, but if it's the first time you've seen it, you're probably like, oh my God, what's that? But what we've got over here is the little clever bit down the bottom here. We're actually using the Max forward device to forward any MIDI information we've got from each of our multi-timbral parts, like the bass or the melody or the high part, and we're using the forward object to route that information through to a different track in Live. And that's really the way you can bypass some of the limitations of Max for Live's input-output routing in Live's chooser for Max data. If you use Ableton Live, you probably understand what I'm talking about. But this allows us to send MIDI data between Max patches on different tracks. And that's kind of clever. That's the sort of the key functionality really behind how this patch works, is using this forward object, which is super useful. So what you sort of got here again is a sort of similar bunch of information. You've got here a little clock that generates BPMs. We're using lots of metro objects that are all running at different tempos inside Max. So we're generating pulses at quarter notes or sixteenths. We've got a rather sort of big, if you like, collection of climate data that Milton sourced. Here you go. So you can see the first couple of sections have got lots of sort of empty data because they didn't really take complete records until 1993. So when we scroll down, we'll see some of the data becomes a little bit more useful. And what we're actually really doing here is sequencing through this data and spitting it out and then scaling it to maybe different types of MIDI property, whether it's note or velocity, etc. So a lot of this patch is quite similar to the other two, but they're obviously not using an API in real time. This one is really pulling information from a cull or a call. So with the Max cull objects, you can actually do, you know, a whole bunch of crazy step sequencing with these by stepping through the actual objects within your column or your collection, or your data storage object. Just by sending different bangs into it, it will just spit out the next entry in the list. So we're sort of using it as a primitive step sequencer. We've also got over here a separate call for velocity, so this produces all the MIDI velocity. This is pretty much similar again to the previous patch we showed. We've got over here the first object or instrument to do pitch and velocity. Here's the second one. Here's the third one. So I mean, there's quite a lot of repetition in some of the building we've got in Max here. Probably could be optimised a bit. So if you've got any advice for that, guys, I'm all ears, you know. But at the moment, these are sort of working fine, and you know, it allows us to sort of use a slightly different approach, really. As Milton was saying, this is data that we've discovered. We've loaded in from a spreadsheet into a CSV, and we've loaded it into a call. So this one is not using any real-time data off an API on the internet. Yeah. So let me just come back to the main window for a bit and just see if there's any questions in the chat at all. Doesn't look like it. So, yeah, so I was trying to zoom in a little bit on the Max for Live device there, guys. So I know there's quite a lot of big information here. We're trying to sort of get through quite a wide topic this evening. So I'm hoping that you could see that. But obviously you can get these patches from the Music Hackspace forum and you can fill your boots and have a look as much as you like, yeah? And to answer Cassie's question, it is cheating, but as Milton would also say, a lot of the parameterization you might choose to do as a musician can have great different results on how you use that data. So, you know, Milton created examples from the same data I did, and my results are very different musically from what Milton would choose, just because of the, you know, some of the scaling or some of the parameters we choose. So there's still an element of individual control you can have over this. We're not all going to come up with the same musical motifs just for pressing play, yeah? So guys, I'm going to hang back to Milt. So thanks for your time, and don't forget, throw questions into the chat. See you a bit later.
Hey everyone. So I just respond to that cheating question. First of all, all's fair in music making. That's the first thing. We don't think it's cheating to use a piano. But secondly, and more importantly, what really fascinates me about this world is that it gives us a way of understanding the world, the universe. And our musical listening faculties are extremely sophisticated. And I think that we can hack them in order to understand better the world. Now, in some cases, that means a microtonal glide is more sensible, maybe for temperature. In others, a discrete 12-note slice or a 7-note slice is more sensible. It's exactly like what we do with graphs. We don't think anything of us using a scientific graph to represent data. It isn't the data, and it's an abstraction, but it reveals some important pattern. And what we are creating here is musical graphs, sonic graphs. And you know, I'm up for generating any musical material anyway, but what I'm supremely interested in is actually hearing meaningful, expressive, communicative information through music. And that brings us to the next topic. We talked about music of the physical world, of the solar system, and of asteroids going by, but of course anything makes music. So we can make music from animals and humans, for example, and the connection to our bodies is deep with music. You'll notice that the most metronomes have a range of tempos that map really closely to our range of heartbeats. So the slowest music you'll generally feel as a one pulse is a 40 BPM, which is a tennis player at rest, and the fastest is probably in about 200 to 220 region before you start half dividing it, doubling it, which is like someone on cocaine late for an exam. So we have that full range that we are tapped into. So and people through the ages have talked about the music of the human and animal body. Now I've sonified previous viral outbreaks, which I won't play you, but a really formative experience happened to me back in 2004 when I was starting to do this work, and I fell ill, and I later very soon discovered that I had a form of leukemia just from one mutation in my blood system, and I was put in isolation on steroids with nothing but a laptop. And so I took my daily blood results and noticed that they had interesting, almost musical patterns within them. So started writing a piece called Bloodlines, which every day of treatment is 1 second of the music. So this seemed to go beyond just the simple translation, but told the inner story of my health experience. I'll just play a short extract. So that's the second going by, that's a day. And I know every one of these days as they go by, and each blood cell type is describing those days of experiences as I went through leukemic crisis. So in a way, I wasn't composing this, it was my blood cells. I just collect the royalties on their behalf. So this allows us to go deeper still and capture a sort of human experience below the surface. There's the data from that, using similar methods that we're using with climate. I've been working with Oxford neuroscientists in the conversion of what happens in our brain when we have various experiences. And this is amazing researcher called Phelan, who mapped the brain harmonics. Basically, she can describe any brain state in terms of harmonics, just like we can in terms of timbre. So, for example, we have a different profile when we are depressed or when we are on LSD. And apparently there are other states to be in. I haven't found them yet. So I'll show you a little example. This is someone on placebo and the sort of melodies that they make across their brain. And someone on LSD. That lovely high note, I love it. So we can start using music as a tool to uncover our deepest, even incommunicable, otherwise hidden, deep human experiences. And also how we vote. This is the signing of the petition to revoke the Article 50. Seems so long ago now, and I mapped the real-time responses to get a sense of the speed that happened. I don't know if I've got that here. I'll send you the link later. I don't seem to have it right here. So, and I've connected the mouse heartbeats to play massive modular synthesizers. This one I'll show you because it uses Max directly. We hooked up, this was at the Frank Moyer Institute with a student there. We hooked up a live camera onto a spider web and basically treated it like a harp. So if there was any movement along these threads, you would get basically sound coming out. So the wind going through triggered these, and you can hear the background sound at the same time, which I think is quite beautiful. Let me find that. Web strings, here we go. That's the bass right here. So what we're doing is listening to the biological world in a deeper way than just simply recording it. Martin had made a comment earlier when we were doing the crypto sequencing, which is you could actually listen to DNA code, the genome sequence, and that's exactly right. I started doing that back in 2006, and actually just this week I've been working with Dr. Enzo De Sena at the University of Surrey in converting the mutations that are happening in the COVID-19. So for every note sung by the choir, a mutation triggers a single note. So the COVID-19, you may not know, has been through 500 generations already. So I'll just play you a little. So this is how it might start. And as the generations move on, we get this broader and broader choral piece. It's 42 minutes long, and I just keep listening to it. I find it utterly beautiful. So the position in the sequence and the type of mutation is instructing the musical choices there completely, and it's hands off as soon as that system is set up. Another project I did was basically take a 24-hour footage of a road in Surbiton, if you need to know, and basically treated it like an orchestra. So the string section is here, percussion is here on the fast loading zones, and horns are there, and everything is sonified basically. So the traffic throughout the day is realized. I'll show you a couple of short clips here. So I still got this piece running, so I'll just stop that. Let's find it. Here we go. So you'll hear the string sections as people park on the right occurring. You may have heard that one. And as the day gets busier and the people are double parking, you start getting discords right here, which I love. And there's one point here, because it's all rule-based, where someone spills some water on one of these loading bays. There it is, coming up right here, and it sets off the symbol. I love that. I'll just show you that one again. Someone comes... Okay, there's so many I want to show you, but we're running out of time. I did this TEDx talk, and as the people were sitting down, I had it hooked up so it was essentially a harp, and where people sat, played a piece of music. By the time my talk had finished, I'd managed to produce it. So it was super fun to do that. Let me show you a couple of other things. Okay, so we're going to end with this one here, which is essentially probably the most profound connection from the physical world to music, and that is in light. And many people have seen that connection through the ages. There's lots of similarities between light and color and music. We think about frequencies. There's a frequency range that we respond to, so that's a connection there. There's amplitudes, and in fact, when we talk about the 7 colors of the rainbow, where there could be any number of the rainbow, it's a continuum. That actually comes from Isaac Newton, who loved music and wanted there to be 7. That's why indigo and violet are a bit like, He came up with these 7 to reflect the musical scales here. And Isaac Newton did it back in 1704, but there's been centuries of color scales, the connections between the musical and light world. Kandinsky talked about it, and he called his paintings improvisations and compositions. And I developed this, and Fee helped a lot, so thanks Fee. Called Kandinsky, of course, which essentially does that. It tracks color data onto pitch data, and I'll show that right now. So here she is. So what we have here, just to explain, these are the different color scales through history, connecting notes, colors to notes. And essentially we have a color that occurs and a note that plays if it appears. So if I move this around, it'll pick these up. And I'll just talk through what I'm doing because it will help me anyway. But I can basically make a trajectory that comes through here. So I'll say I'm going to start here and I'm going to end here. Let's go with Dorian. Now, Newton didn't have these chromatic notes in there, but so we're going to get a lot of gaps here, and these won't necessarily match. Great. So we get 1. We could increase the sensitivity so it might hit a few more of them. But really what we want to do is pull out the colors that are in this particular painting by Bridget Riley, by the way. And so we can kind of map it. I've built up this auto map feature. I could do it by going onto the colors and say, right, I want you to be 1 and you to be 2 and so on. But I can do it this way. If I just hit play and I'll auto map. And auto map these guys. Cool. So we've got this nice groovy sequence happening, which is basically reading it. And we'll get a different sequence if I do a different and I can change these notes. So that F, I'll bring the A down. And this is MIDI data, so we can do a whole bunch of stuff with it. I could add it to a different instrument. And what's really cool is I've made these buses. So for example, if I want this note to also trigger something else, that's note 4. So you can see that being triggered. Note 4 I could send to maybe a kick drum to play a I could literally do this for hours, and if you see on my Twitter feed, I've done this for people. I do dozens and dozens of these, and they all sound different, and I love it. A couple of people sent some stuff in. Oh, I should say at this stage, I didn't want to miss out. Ginger asked, have I found universal truths with this? I find them daily. I've collaborated with people from all sorts of disciplines, and have never found something uninteresting or musical. And I'm learning through this language as my collaborators are. So I think this way of making music, or I don't even think of it as music, it's sort of discovery for all parties involved, is all about universal truths and nothing else. So I had a couple of requests. So by the way, I can put in any painting I want to and throw these in here. I'll do that. I'll go with this, run that off there, and do a stop, set there, set, do an endpoint, and let's go. That's cool. Super fun. I'll stop doing that because you're just going to be watching me have a good time. So let me open something up. So we got a couple. There's this one. I'm not sure who sent this. I didn't get the name, but if JB can tell me, I can say it. So what shall I do with this? Well, it's quite muted. It's got quite muted tones. So we probably want to somehow get that sense of color scale here. So if I go here, let me go with this. I'll set that position there. We want to auto map those colors. Let's see if I can. I'll slow it down, make it go across. Yeah, I'll do something complete later. Let's see. We got Laura sent this, and oh, that's beautiful. Let's go with. So we want to kind of capture that. So we'll go quite slow, and set that as the start point. That is the end point. We want to start. Let's get those colors in. There we go. We're going to start there, and we're going to go end about there. We'll do it across 4 bars. What you can also do is map the red, green, and blue content. If I hit play, you'll see it. Move on. Let me just slow this down. Auto map it. Okay, and all right, we should be able to open this up now. So bus 1 pad, bring this over to here, and let's bring this up. I'll map this as it goes by. I'm not getting over that pink, so I'm going to go this way. It's pretty risky of me, isn't it, doing this live? Oh well. I like that. So we get that high note there, so I'm going to play with that. And we'll bring this one down. There's a bit of a gap here, so I'm going to put a note in. We should. Let's run across here and do this. yeah, I'll stop there. So that's our talk. I don't know if there's any more questions. I want to go and clap for the NHS real quick, so I might have to jump back in. But it's been great talking, and we're happy to respond to all of these. And I'm going to flick back to JB now.
Thank you, Milton. It was really a fantastic talk, and thank you also for encouraging the health worker here in the UK who are risking their lives every day to make us survive this virus. And it's a beautiful tradition. I can hear it from where I am right now near Tower Bridge as of my background. I can hear people outside cheering. So it lasts a few minutes, and I hope that Milton will join us back after this. So everyone is at the window and cheering for the NHS National Health Service. So a really wonderful talk by Milton and Phelan, and you can, if you dropped out, you can watch again later. You can watch the beginning if you arrived late. It's really worth watching through. So we will take more questions after this round of applause ends, and Milton is back. Phelan is also still online, so you can answer any questions you might have. Hey, Phelan. He's waving.
Hello.
You can't see him. So yeah, I mean, I have a few questions for you. I mean, like for you personally, Phelan, were you into data sonification or making music with data before meeting Milton, or was it like something you picked along the way?
I sort of picked up a lot of this inspiration from Milt, but I was definitely into making weird max patches to do strange things to music. And coming from a bit more of an engineering background, you know, I'm a bit more of a technician and Milt's a bit more of the musical genius. So, you know, I guess I mean, we also collaborated on projects a few years before about rhythmical stuff that we did at Loop for Ableton. So we, you know, for me, it's exciting to be able to manipulate sound with patches you've made yourself, whether or not maybe you're reading off a data source, you know. So I guess it's the parameterization of being able to build something yourself, to be able to create something new is exciting, you know.
Right. So and the patches that you are making, I mean, you're making Max for Live devices. So if people are not familiar with Max for Live devices, these are kind of plugins that work within Ableton Live.
I mean, they're just really sort of, they're Max patches in Live, really. So there's a couple of just caveats about if you want to rip them into a standalone Max device, there is a couple of objects that come with the Max for Live landscape that allow you to pump MIDI and audio between your patches. But they're just standard Max objects. So if you have full Max, you have all the functionality of Max for Live. There might be some hacking you might need to do to be able to use them standalone in a version of Max. But I'm more than happy to help people out with that. If they've got any questions, you know, you could just find me on Facebook and email. It's just a couple of objects you might need to add. For example, add an easy DAC as opposed to using a plug-out object if you're using audio. But for me, Max for Live is a bridge between Live and Max. So it's not really like a separate programming environment. It's just really a software license to be able to use Max within a live environment. And we touched a little bit on the live object model where you can basically automate and script your DAW. So that's stupidly powerful. You know, you can have Max objects that could be producing random number generators that might be, you know, routing audio through different aux sends in your live mixer. And that's one of the great things about having that Max landscape with Live, because you have that sort of deep integration. Obviously Ableton owns cycling now, and it's quite beautiful because the very first version of Live, version 0, was built in Max. So the whole thing sort of, you know, come around in a full circle, if you like, really.
Cool. And there was a few questions from people watching about where they could find these Max for Live devices. So I understand that some of them will be on the Music Hackspace forum, which is great. But we've seen 5 or 6. I suppose some of them are used for your own practice or Milton's practice. Are some for sale? Are some, you know, for public consumption? How did that work?
Well, we're quite happy to give them all away. The one we're going to keep is the final Kandinsky one Milton showed at the end. It still needs a little bit of work in progress because unfortunately it's a bit overwhelming, that one. Milton knows it intimately because, you know, me and him spent hours and hours and hours working on these things. So we'd like to be able to make the Kandinsky patch a little bit more user accessible. So what we're going to do is we'll put onto the forum, the Music Hackspace forum, asteroids and weather report and climate data, the crypto and the crypto sequencer. So we're going to keep hold of Kandinsky for a while yet, but as Mil might be able to also say, we were scheduled to do a talk based on this presentation tonight at Ableton's Loop, which was rescheduled for next year. So if you come to Loop next year, you might see version 2 of the patches, and you might be able to get a sort of upgrade from us as well, yeah?
This is great. And Milton is back. So how is the clapping, Milton?
Clapping's great. It's always really emotional. It's awesome. I love it. So just to respond to that, yes. So Kandinsky, I know well, but it's really, it's quite hard to use as Fee as Fee discovers when he tries to fix it. But there's one thing I was going to do was the Max logo. I can still do this now, but I think you get the idea from what I demonstrated. So I don't know if I missed any questions, but just to reiterate, I find this sort of mode of practice deeply profound, actually. I don't have other words for it because it seems to melt away the constraints we put around music in terms of what it can be or what should be. Should it be a commodity or only for people with so-called talent? Where I think it's a mode of engaging with the world, and concepts like this, and actually now enhanced by technology, means that it's music can be less thought of as something that is for the few talented ones, or is something that is rare, but it's just universally available to all of us, and it's just a way of encountering the world. So that's my perspective on it.
All right. Well, I have a serious question that's coming from me, actually. So the question is, you know, when I watch your TEDx talk, Milton, you know, you said jokingly to the crowd, well, you know, you're uploading yourself because you actually made the composition by sitting down. People, you know, and I thought that was interesting because with AI, you know, in machine learning, now you can take two songs and an algorithm and make a new one that's completely copyrighted to you as the author of the algorithm. And I think, you know, underneath the joke of, like, you know, the data itself being non-musical and then you actually putting it to music, there is a serious question about copyright, about who does the music belong to, and I just wanted to get your sense of where you are with this question.
I mean, it's like photography, I would say. I mean, this music, a lot of this music is like a beautiful beach, but as soon as you take a photograph of it, it's somehow yours because you've created the frame. And I think these are essentially frames. Now, if you took a photograph of someone's image, then there are ethical issues. So I've never thought of it before, but I have a strong ethical approaches to what I sonify now. I'm careful about, I've done lots of ones on birth and death rates and people dying and so on. And I'm now really careful and sensitive about that because somehow you're framing it and discussing it. It's like taking, I've never thought of this before, so thanks for the question, but it's like taking a photograph of someone's experience, and we should be, well, I feel I should be not be flippant about that. As for ownership, I don't know. I'll take it for the time being. I'll take it for the time being. I think that, you know, that's a problem that stems into music anyway. We have 12 notes, usually 7. are going to be combinations that come up again and again. So it's a personal perspective, really. And I don't think this is any different. You're taking a personal perspective on the world. And as such, I guess you own it. But I've had a long issue with the idea of ownership of music, and also why I was making music. It didn't feel right to write love songs. I love love songs. I love pop. I love loads of pop. But it wasn't for me just to write another song about love. It just didn't feel like it was needed. And these feel like something that I can do. So there's individualism here as well.
Great, thanks. I have another question, which relates to the length of compositions in general. I mean, as you yourself, head of composition at Surrey, I mean, you teach, I suppose, different forms of composition, and it looks like from the example we have, the data signification is great for short form. But have you done like longer form of composition, like
well, that
45 minutes of music?
That COVID-19 was 42 minutes, so almost. Yeah, I've had I've done the Galaxy ones that last a long time. And in fact, the solar system one is indefinite because they never wrap around. So conceivably, you could run it on forever. I wrote this one piece called Irrational Music, which was based on irrational numbers pi, phi, and E, and so it was provably non-repeating, so it would run on infinitely. So yes, you can do that, and you can actually employ a strategy so that you'll never hear the same music ever again. But it's interesting, that one of duration. I have a series called of geometudes, which are geometrical etudes, which are just two objects intersecting, and you can do that slowly or quickly. I'm just going to show you just a little bit of it. So this is, if I may, so this is for hexagon and line. You can see that, right? You can see that hexagon intersecting with that line. Sorry, I'm sharing now. There you go. See that now? Okay, great. So you see a hexagon intersecting with a line, and let's check you've got that. And as they connect, each of these vertices have a note. So we get a nice satie phrase. And as it turns, you get a different phrase, different rhythm. And this one blew my mind because it sounds like expressive music. And it's changed my entire thinking about structure and motif in music. If we think about motifs as shapes intersecting, we suddenly have a language of rotation and of intersection. Our language for music is generally quite impoverished, and so we can enrich it that way. And that goes to duration and structure also. So like those Skyline images, you start thinking about, can I have a palindrome, like a window in the middle of a piece? And the answer is yes, obviously. Let me stop that. So yes, it informs all manners of music, including structure.
Great, thanks. So when you were away, I had a question to Phelan, which was related to what is the intention with the Max for Live devices that you're releasing? If it's kind of a commercial initiative, or it's more like to fuel your own composition, and you're happy for them to be used by the community, or a combination of all of that? And maybe you can complement what Phelan has said.
I'm not sure what Fee said, but as you can see, I'm not struggling for money, so I mean, I rarely have sort of mercenary gains for all of these. There is for the first time, there is some sense of, well, we've worked really hard on this and I want to do some stuff with it before it goes out to the world. But in general, we're super, I'm not sure what Fee said, but we're super open. I know that we have some plans of publishing it. So it'd be nice to have it published, maybe with some low cover the bills nominal fees. But the nature of Macs and of this sort of music making, which I love, is very open source. And I think that's generally going to be the strategy here. Did I say anything wrong, Fee, or am I pretty...
Hello. No, I think just, yeah, you sort of agreed with me. I guess what we were trying to do was to sort of have a chance to road test these devices in environments like this. We've done a similar thing for Ableton Glasgow. We're doing Loop again. And maybe in about a year's time, Milt, we might be able to sort of publish these up and get them a bit more user-friendly and a bit nicer. Maybe release them on Isotonic Studios or something by our friend Darren. But I think for now, you know, we're happy to release the first couple of patches for people to hack into. I mean, I learned how to use Max and Max Fly by downloading other people's stuff, so it's a nice community spirit to continue that, you know, methodology really.
Yeah, absolutely.
Well, this is great, and I look forward to having access to those patches and test them myself. Well, that's great. I don't see any question coming from the live stream. But I want to thank you very much for joining from the beach and from San Francisco. You know, I'm stranded in London here, so you know, I feel I have the wrong end of that stick. But yeah, so thank you so much.
Thank you for setting this up. I think it's a really great initiative, and I hope people are getting out of it what I am too. It's a really wonderful thing, and I just want to say, be safe and well to all the viewers. Thank you very much.
Thank you, Milton. Thank you, Phelan.
Thank you, everyone. It's been lots of fun. Good luck. I'll see you on the next one next week. Ciao.
All right. Bye-bye.